Welcome back, students. In this video, we're going to cover lesson 5-6. This is isosceles and equilateral triangles. Benchmark standard for this lesson is GR 1.3. They're below the title. Just a second. All right, on the left, so isosceles, that's a triangle that has at least two congruent sides, or we'll also say legs, now that we're discussing legs with right triangles, but just want to make sure we all know we're talking about the same thing. So let's see, just do this. Over here you've got your isosceles triangle theorem. Kind of goes along with that. I'll do that, then we'll talk about the equilateral. Hang on, what is the deal? Okay. All right, so isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So for here, so these two sides, and so the angles, so notice the side opposite of 1, the side opposite of 2. So let's see. Actually, let me pause. Okay. So in this case, if AC is congruent to BC, then angle 2 is congruent to angle 1. And the way I like to describe it, so this is the base, these are the base angles, and the sides opposite the base angles are congruent. And I believe in class I drew this with this side down. But either way, the opposite sides, the opposite angles. So equilateral triangles, when all sides and all angles are congruent. So, you know, the interior of a triangle is 180 degrees. And if we have three angles, three sides, well, the only way mathematically to get 180 and the three are equal is by, if you divide 180 by 3, you get 60. So that's why this is important. Because if two of these angles are 60, so you can, an isosceles has the two sides congruent. Equilateral has all three sides. But if these two are 60, and this being an isosceles triangle, well, 180 minus 60 is 120, minus 60 is 60. So mathematically, if you have two angles that are 60, you have three. It's impossible to have two without three in this case. Now, to find the distance of a line segment, you could use Pythagorean theorem or the distance formula. Now, both of these are on the reference sheet. We're going to use the distance formula. We're going to use the coordinates. I've already put these below here. And let's go into this first example. Excuse me. So, example 2, find the measure of angle B and angle C. Determine the side relationships and determine the angle measures. So we got a 70. So remember what I said above, if you have two 60s, you have 360s. So this is not an equilateral triangle. So, but we're going to check out, since we know this is 70, let's check these two sides. If these two sides are congruent, these two angles are congruent, and we already have one, so that'll help us there. If not, then we'll check these two sides. If these two sides are congruent, and it doesn't look like they are, we can kind of look at these numbers and see. But if they were, then these two would be 70. So we would just have to subtract these two guys from 180 to get C. But let's see the side measures first. So I'm going to use distance formula, part A. So we're going to start with AC. So, all right, so my coordinates A was 0, 3. We didn't go left to right, so that's why the x coordinate's 0. I like to go over these things just to help keep everybody on track. And we went up 3, so that's why it's positive 3. And then over here, C, we went over 4, or left 4, so that's negative 4, and then we went down 2, which is negative 2. B was positive 4, positive 4, negative 2. So see, these numbers, when you look at them, when we square stuff, remember the negative and positive doesn't matter. So if you have the same x, y, this would be your, say this is your x1, y1, this is your x2, y2. For this side, this is your x2, y2. So you essentially have the same equation, but let's look at it. All right, so our x's, excuse me. So these are our 2's, these are our 1's. Let me just, I've been doing this, so x1, y1, over here x2, y2. And this is going to be x2, y2, because I'm going to measure here, then here. If we go this way, then obviously this will be my x1, y1, but let's see. All right, so negative 4 minus 0. And then negative 2 minus 3. All right, so negative 4 minus 0, still negative 4. And then over here, negative 2 and negative 5, I'm sorry, negative 2 and negative 3 make negative 5. Of course, these are both going to square, and they're going to become positive. All right, so negative 4 squared is 16. Negative 5 squared is 25. Add those together, and AC is going to equal the square root of 41. Right now, we don't have to take it out of radical form. We'll be able to tell if they're the same number, and then if they're not, and we need to look further, we can go further. But for now, this is sufficient for the measurement here. So let's go over here, and we're going to do AB. Oops. And of course, again, so x2, so instead of negative 4 and 0, it's going to be 4 minus 0. So see how this is going to be 4 again, which is going to square and make 16. But let's go with it. You're probably like, shut up and do it. I will. Negative 2 minus 3. So these are exactly the same. So we got 4 squared plus negative 5 squared, which is 16 plus 25, which is the square root of 41. So this means that AC is congruent to AB. Okay, which we'll go ahead and do this and do this. Okay. All right, so if these two are congruent, these two are congruent. So that means that angle B is congruent to angle C. All right, so what do these two guys equal? Well, we have the whole triangle is 180. We subtract the one angle we know, so we subtract 70. We get 110 degrees. All right, both of these are equal, so both of them equal 110. Divide it by 2 to get each one, right? Okay, divide by 2, and that gives us 55. I know we got into the measurement there, but 55 degrees. That's going to be 55 here and 55 here. So 55 and 55 are 110. 110 and 70 make 180. That's how we know we're right. So let's trickle on down the page here a little. Example 2 check. So find the measure of XYZ and find the measure of angle YZX. So XYZ, so they want this guy. I'm just doing that. And then YZX. So they want these two. So you can also have an isosceles right triangle. So just in case that's what this is, you know. So this guy's 90 degrees. You're going to check the measure of AZ and AX, and if they're the same, you can say these are congruent. I didn't mark these congruent. I'm just showing that these are both what we're talking about here. So find the measure here. If these are congruent, that means these guys are congruent. So it's 180 minus 90 divided by 2 would give you that. So I'm not writing it out. I am explaining it, but that's the benefit to the video. If you can watch and listen, not just watch, then you might learn something. Oh, another highlighter. Okay. All right, and I apologize. This has already been written on. I didn't realize it, but that's okay. So example 3, find the measure of angle J. So now we don't have anything marking anything congruent here. All we have is this. And I've sometimes we get caught up in the congruent marks, but if this is 12 foot and this is 12 foot, they're equal or they're congruent. So these two sides are congruent. That makes these two angles congruent, right? Well, that's what we learned above. And remember, if I said if you have, so if this is 60, this guy is 60. Okay? And if you have two 60s, you have to have three 60s. That's what I had said at the beginning. So if one of your two congruent angles on your isosceles is 60, then you have an equilateral. So of course those are 12. And remember, if the sides are congruent, if the angles are congruent, then the sides are congruent. So this is an equilateral. I did have it written out, the proof version. Let me just write it here real quick. So we have, this is find the measure of angle J. All right, so angle, well, JL is congruent to JK because it's given right here. And that means that angle J, back up. That means angle L is going to be congruent to angle K. And that's isosceles triangle theorem. All right, don't expect you to know all this. This is just me trying to help you understand where we got this, because I know I went through kind of fast, and we need to know, geometrically speaking, how we got here. So now we know these two guys are congruent. All right, so what would be the next step? We know they're congruent. Let me think. So I don't know how I would exactly word this, but so to find angle J, so then it's angle J plus angle K plus angle L equal 180, and that's just would be definition of a triangle. So then we say, looking for angle J, so it's 60 plus J equals 180. That's substitution. Again, you don't have to know all this, but I want you guys to kind of see it. Okay, so now we subtract 60 plus 60 is 120. So now we come down here, and you got angle J equals, so these two cancel. This is 60, and this would be, you could say solve, but in this, well, actually, so hold on, substitution. We subtracted the 120 from each side, so subtraction. So yeah, then it would be solve, or whatever you want to say. And that's why it's equilateral, because 60, 60, and 60 make it so. But hopefully this helps. No word bank. This is, and I've told you guys, I'm definitely not a mathematician or anything like that. I teach this and try to hope you guys understand it. So as we flip the page, and I wasn't gonna do one, but because I get very few responses, which tells me very few are listening. That's okay. If I get one of you guys, and so oftentimes it's just one, that's okay. That's why I do it. But Your so your bonus word is teaching. I'm going to put that here. And that's why I do it, because I like teaching and I care about you guys. So anyway, example 3 check. So find the measure of angle R and then PR. So you're looking for this angle and then this side. I've already said, look at what you've got. They give you the measure here and the measure here. Hopefully, if you guys have been paying any attention, this should not be a problem. We'll see. I'll let you guys go with it. So yeah, give me the angle, give me the measure of angle R, and give me what PR is. So now, example 4. So we're going to find the value of each variable. Okay. Now we have y's and we have x's. We can't find x and y together. So, and also let me zoom in just a little. So here, notice the degree sign. That means it goes with this angle. Degree sign, it goes with this angle. This is a side. This is a side. Now, a couple of things, it is difficult to see, but there is a congruent mark here and here. Can you see those? Maybe. So these two sides are congruent. So which means these two angles are congruent. So that's how we're going to solve. And like I said, notice off the bat, we have x's and y's. We can't find them both together. So you either, if they are in the same equation, you separate them, find one, and then use that, plug it in to find the other. In this case, we're going to put stuff, the x's will be together, the y's will be together. They're not actually combined. I think there's one of those on the review. But anyway, so for x, we have angle A is going to be congruent to angle C, which means 60 equals 6x plus 6. Okay, I'll separate this like that. So subtract 6, those cancel. 6x comes down. 60 minus 6 is 54. We divide both sides by 6. And x is going to equal 9. So they asked for the variable, not the angle, so we're good there. So the y's. Let me see. Oh yeah. Well, important here. So remember, so we got 60. We had these two sides, which means these two angles. So if this is 60, this is 60. Remember, if you have two angles equal to 60, you have 3. Very important. If you have 2, you got 3, and I know. So now, that means that these two sides are equal. And actually, all 3 sides are equal. Because these are 60, so this equals this equals this. So now we just put these two equal to one another. We had to do all that to know to put these two equal to each other. Otherwise, if they're not equal, you can't solve for y. And they're not going to ask you something you can't solve. So if you can't solve it by what you're looking at, then see what you're not looking at. Because we're missing some geometric type thing along the way, some rule that I've said, and that's where they like to get you. So that's why I say if you have 2 angles that equal 60, then you have 3. All right, let's solve for y. 4y minus 2 equals 2y plus 2. The 2y is smaller, so I'm subtracting it from both sides. So this cancels. You got 2, negative 2 here, and then 4y minus 2y is 2y. Add 2 to both sides. 2y is going to equal 4. Divide both sides by 2. And you get y equal to 2. If I got to scoot it over. Should have done that earlier. My producer is terrible. All right. Example 4 check. So Example 4 check. All right, architecture. The main entrance to the Louvre Museum is a unique glass and metal pyramid. Find the value of each variable. Okay, so see, you have, well, I'm not going to give too much away. Sorry. I would, extra bonus word, my mother-in-law went to the Louvre recently. I mentioned that in class. She went to Paris. Actually, she did not go to the Louvre because the crowds are crazy. And I think she was there very close to the time they had that theft or something. So kind of glad she didn't go. So second bonus word for this video is mother-in-law. Okay. But you're going to separate here, see what you got, solve for x, solve for y separately. All right, let's just scoot down. We have 1 through 6 on the practice. We have another extra practice that I've given you guys. I'm not in school today that you would have worked. But anyway, the extra practice section, there's only 6 in there because they're all proofs. So the summary: if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if the two sides are congruent, then the angles opposite, so here to here, here to here, are congruent. Let me zoom out one. All right, and then number 2 says, when asked if the true statement Tammy indicated an isosceles triangle has 3 sides equal, is the statement true? A always, B sometimes, or C never? I will let you, I said the answer to this at the beginning of the video, so hopefully you caught it. Have any questions, let me know. Until next time, have a good night.